All right, let's begin. Okay. Okay, if you want to see the dog, we can call the dog. Hey, dog. Wanna come here? Come on up here. Yep, your dog. Can you look at the camera? Like right here? Nope. Okay. Yeah. Come on, just look up. There you go. Yeah, that's right. All right, dog. You want to do some loops? You want to learn about for loops, 2D lists? What do you think? Okay. No. Okay. Yeah. This is her normal. Yeah, so, alright. Now go away. Go away now, dog. Do your thing. Yeah, her name is Pupper. So, I usually just call her Pupper. Or Dog. Yeah, she's very interested in loops. She basically lives on in a little while loop. Okay. So, now that I've wasted some time, let's begin. So, oh right, I should always have to change the font size up and then back down after every lecture. So, okay, here we are. Yeah, that's why the homework said walk pupper. Yeah. Okay. So, let me pull up my slides for the day. And let me see. I'm thinking today is going to be a little bit of 2D lists. So basically the agenda for today is probably maybe 2D lists, a little bit more about for loops, and we might start on while loops a bit. I think I also have to talk about split and strip for strings. And so I'll try to get to at least some of these topics today. Let me just see. Yeah, so lecture 7, at least it was, strings and while loops, so maybe it'll be some kind of hybrid lecture here. We'll talk about all these different things. Okay. So, basically, I guess the moral of the story is like recall, right, from prior lectures. We have two types of for loops. We have for each loops. So for each, so if you have a list, is say, X, A, R, B, T, X again, Q, Y. Each in the list, you can print out, the letter is each, right? And so what this is going to do is it's going to print out one letter at a time. So for instance, well, I can just run it. So you see here, it's going to print out each thing in the list, and it's going to do whatever it wants to do on that thing. So remember that at the end of every for loop, you need a colon, and at the end, all the code that you want inside the for loop has to be tabbed in by 1. So this is what we usually call a for each loop, and the reason why it's a for each loop is not because the variable is each. It's because it's not an index into the list, right? Like if I said each, I don't know, is equal to R, and then I printed out the list at the end, this wouldn't affect the list, remember, because the point is that even though we've changed each letter inside of the loop, it doesn't affect the result. And the reason why is because, remember, because basic type are immutable, so that means ints, bools, strings, floats. Okay. So that is the for each loop. Now remember about the for I loop. So the for I loop is basically the same type of thing. So for instance here I'll write a for I loop. Right, and so we'll say if the list at the index is equal to Q, then we'll replace it with QU, for instance. And then here, we'll print out the list again. And so if we do this, then what we see is that when we hit the, yeah, you can kind of see that each is kind of, I mean, I wouldn't really call it a local variable, but it's kind of a local variable. Yeah. It's so the thing about it is that it's a local variable that kind of keeps existing outside of the for loop. So for instance, if you print each, it's still going to exist. It still exists out here, but it's always a little bit dangerous to use it here, because remember, each is out. You know. Oh, okay. Well, let's see if it hates me. You see, even PyCharm is like each cannot be defined, but then you say, wait a second, the for loop actually defines it, and then remember, it's just whatever the last value from the list was, or it's whatever the last value in the list got changed to. So it actually, even though PyCharm is yelling at me, it actually still exists out here. Python doesn't delete the variable, but yeah, just be aware of that. It could always cause you problems if you have like another for loop or another thing that, for instance, if you're like, oh yeah, each is equal to something, and then you get rid of that line of code, it could actually cause you issues. Okay. So remember that the for I construction basically always involves the range object. And so the range object is a kind of weird thing, because it replaces it into a new variable. I don't know. I don't know exactly what you mean by that. Basically, each is declared here, and it continues to exist after the for loop, but it's generally bad practice to be using it unless, of course, you absolutely know what you're doing. PyCharm seems to not like it. So the range object is kind of weird object, actually. So range, for instance, if I make it, say, range like 100 million, so here's proof that it's not actually creating a list right now of these elements, right? Because it did that very quickly. For instance, here, if I let's make it something less. If I make it range 10 million, and I print the range 10 million, and then I print list of range 10 million, would it error out in more cases than not? So the thing is, I don't think it's ever actually going to cause an error in the sense that it won't stop the code from executing, but the problem is that the code will execute, and something will happen. The question is it what you expect to happen, right? And that's going to be the confusing part, right? So the thing is that I would say that sometimes it's almost better if your code just fails to compile. At least when you're writing it, right? I mean, of course, if you submit code that fails to compile, that's not good. But if you had a choice of like, my code fails to compile and there's a simple error that I can fix versus I actually don't know what's wrong with my code, it executes and does something completely unexpected. Those are usually the harder errors to fix. And so that's the only reason why I'm talking about this. Yeah. So here's an interesting thing about range. Yeah, exactly. It's a logical error. It's not a syntax error. And so here's proof that range is not actually creating this object. So let me show you. So first it's just going to print out this range object, and then it's going to hang for a while. Whoa. Yeah, so you see that took a long time to do. Well, relatively. It took at least 2 or 3 seconds for it to count to 10 million. If I made this, say, 50, or let's make it 40 million and run it again, you'll see that it's hanging here for a few seconds, and here it's outputting everything. And so range is actually doing something different than just creating a list. It's actually allowing you to iterate between the start and the end point a little bit more efficiently. So it's actually not doing this. If you want to make a list, so if, for instance, I say make a list, right, of elements starting at 17, ending at 100 or so in increments of 12, then you can actually do that with range. My crazy list is equal to a list of the range object starting at 17, going up to 100 in increments of 12, right? Because remember that the range object takes a start, a stop, and a step parameter. So let me have a drink of water. Okay, so I've commented that out, so that won't take forever now. So, I hear a lot of those kinds of comments, like I know how to use one type of loop, but the other type of loop is easier. I think the right answer to that, is sometimes that might be true. I think that really, for me, 99% of all the loops that I ever write are for loops. Let's see what prints out. So we see what prints out here is 17, then 29, 41, 53, 65, 77, 89. Okay? So it's an interesting fact here because this will actually give you a nice little list of all the elements that you want. But yeah, back to the moral here, right? So this isn't really programming, this is just thinking about programming. So that means about 1% are while loops. And yeah, so I guess I should say that. The default start is 0, and the default step is 1. The stop parameter does not get a default. But really, this isn't a matter of preference as which thing is better in which situation. So I think that's kind of what I want to say about that. It's when I write code, I never think what would I prefer to do, a while loop or a for loop. I just think, is this a loop that should be written as a for loop? If the answer is yes, then I write it as a for loop. Generally, if you can't write something as a for loop, you'll write it as a while loop, but the while loop needs to be carefully thought out. While loops are definitely more dangerous in a sense that they can if you don't think them out carefully enough, you could end up in an infinite loop, which is generally much harder with for loops, especially in Python. It is possible to do an infinite for loop in Python, but it's much, 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 much harder. Is the stop parameter included or excluded in the range? So remember that the stop is always excluded. So for instance, if I said list of tens is equal to range, whoops. Oh. So I'm going to start at 10, go to 100 in steps of 10, and then I'll print out the list of tens. Then you see that here it goes from 10, 20, 30, 40, 50, all the way up to 90. It does not hit 100, right? Because it stops there. Okay. So that's a bunch of review. So here's something I didn't say about range before. So the step parameter, can be negative. So be careful about the step parameter because, for instance, if I say like for I in range, let's say 3 to 100, and our step size is going to be -3, this is actually just not going to execute. And remember, end is just going to give me... so you might think, oh, this is going to go from 100 down to 3, but remember, this is the start parameter, this is the stop parameter, this is the step parameter. So there's two real possibilities that could happen here. Either this could be an infinite loop, because what it's going to do is it's going to say like 3, then 0, then -3, -6, -9, all the way down to -infinity, right? Or whatever. Or range could detect that 100 minus 3 is bigger than 0, and step is less than 0, and then not do anything. And so as I said, it's not going to execute, so it has to be this one, right? So, so you'll notice that this doesn't do anything. But if we want to actually do something, for instance, for I in range, say 5 down to 0, step size -1, then we can print out I. Whoops, forgot the in. There we go. So, so here is a negative step size that will execute. And you see why it executes, right? Because what it sees is that the 0 minus 5 is negative, and the step size is negative. So if both things are negative, then it's okay, right? So it'll go. You can also do step sizes, like if you wanted to do, for I in range, 10 down to... So if you want to actually... Here's how you actually get to 0. Like if you want this to be countdown, right? Instead of just I. So if you want to get to 0, you need to have the termination or the stop is equal to -1, not just the step. Right? Because if you have the stop is equal to 0, then it's not going to hear, it's not going to get to... So remember that end equals, this just changes the end line character from a new line to whatever you put in. So for instance, if I say print, t minus countdown with an end equals, I don't know, so I guess I should print a blank line here. Yeah, t minus 10, t minus 9, t minus 8, and you see how they're separated by this space, colon, colon, space. I can change this end character to any string, really. So really, it's not even an end character. It's really... and that's just because Python doesn't really distinguish between characters and strings like 95% of the time. There are some instances where it does, but there are mostly instances where it doesn't. So you can have... So negative ranges are completely legal. There's nothing that forbids them. Yeah. So, okay. Okay, so that's the one of the last things I wanted to say about range. I don't think I'd ever said that range can take negative step, but now you know range can take negative step. So does I increase by itself? Basically, well, I guess if you're in C++, right? You need to do like a for into I equals 0, I is less than n, I plus plus. But in Python, if you do a range n, it will take care of that for you, right? Because what it's going to always do is it's always going to increment by the step size, right? So whatever the step size is, it'll increment by that. So, okay. So what's the thing on my list of things to do? Alright, so I did a little bit more about for loops. I talked about negative step size, which should have been on this list anyway. I think we will talk about split and strip before we talk about while loops. So, okay, let's talk a little bit about 2D lists, especially in Python. So, for instance, so what is a 2D list, right? So, what is a 2D list? A 2D list is a list where the elements are lists. That's really it, okay? So, yeah, okay. I think that's really all I have to say about it, right? It's a list where the elements are lists. Let's do some examples. So, yeah, it is a lot like a matrix. The matrix is equal to... And so, let's do something like that. So basically, in order to create a list with lists inside it, here's how you do it. You can do it this way. So, for instance, like 0, 1, 1, 0. And so this is like the, if we print out the matrix, we're going to see that it's... Okay, let's just print this out. Oh, first let's put a end line up here. Okay, so here is that matrix. You might think, well, that's not very, really, like, that's not kind of how I want to display it. Say I want to display it row by row. So generally, the way that you think about 2D lists is in terms of rows and columns. And so what do I mean by rows and columns? What I mean by rows and columns is that if I put an end line here, you'll see that the matrix here has 2 rows. So this is row 0, and this is row 1. So if I access, for instance, print the matrix 0 and print the matrix 1, then what we're going to get out of it, and let me change these numbers a little bit, 3, 7, 1, 0 is fine. Okay, So we see that if we print out the matrix 0, right, the matrix 0 is not just an element, right? It's the 0th row. And the matrix 1 is not just an element. It's the first row, right? So, yeah. So basically, if you ever want to actually go through every element in a 2D list, it requires you to do something a little bit different. So let's say that we have like a 3 by 3 matrix. So let's say here's another grid, and so let's say that the grid is 1 0 1. Of course, I need the extra thing. 2 0 2 3 0, I guess, and then 5 1 8. Okay. So remember, in order to access something in a grid, what you're going to have to do is, say we want to access the element, I don't know, so this is row 0, row 1, row 2, and then here, this is column 0, column 1, column 2. So basically what we're going to have to do is we're going to have to access this thing using the row first. And so why are we using the row first? We access the row first because it's the outer list, right? So for instance, let's say that I want to access row 1, column 2, then what I have to do is do this. So this is how you access a list within a list, okay? And so hopefully this will print out 0, I guess. And it does, so we could even say row 1, column 2. There we go. That way we know what it's printing. Okay. So that's how you access something within a 2D list. So now the question is, what if you want to scan through every element in a 2D list, for instance? So let's say you want to scan through a 2D list. I guess I haven't given a link to the slides yet. I mean, they're on the blackboard, but I'm kind of using. Let's see here. I don't want to give that link. I want to give this link, right? I think. Yes. So good question. So when do you need a 2D list? So I'm thinking our first project is going to be something like Monopoly. So Monopoly actually does not need a 2D list for movement, right? And you might think, well, maybe it does because you see the grid is it's a square, right? But the thing to remember about Monopoly, not sure what that means. So okay, so if you think about Monopoly, like if you go around the board, you're never actually going into the board or out of the board. You're just following a loop, right? And you can actually just use, you can a single list for this. Oh, are we using lists in Homework 3? No 2D lists in Homework 3. I mean, you can, but don't. Okay, So it doesn't need a 2D list. But what kind of things do need 2D lists? So for instance, chessboards, checkers boards. What other kinds of things? Maze problems, right? Anything with a grid. So if your position is measured in X and Y, right? If you have an X and a Y position in a game, yeah, Go board. Which I know everybody buddy loved that project. So for instance, let's see, do I have a Go board up? Yes, I do. Here's a Go board. So if you remember that if you're playing a game of Go, which this is a game of Go that I'm about to lose to the computer, but if you're playing a game of Go, then the thing about it is that you need to know both the X and the Y position. So the Go board here keeps track of the X position. Well, I guess which one is the X position, which one's the Y position. The answer is who knows, right? That's kind of the thing, is like you don't actually know which one is which. Of course, I kind of put myself into that position. You can't actually play here unless you want the computer to capture, so they're going to capture. But I don't care. That's not the point. I was already losing. So the idea here is that this game needs to keep track of all the positions, X and Y coordinates of all the pieces. So that's why you need okay, well, at least capture back to, pretend I wasn't so stupid. Okay, so basically, Go, for instance. Okay. Yeah, right. Okay. So basically, you need a 2D list for anything that has both an X and a Y position, and you can't kind of trick it into not having an X and Y position. So there are certain kind of applications that you can't, like Go, for instance, you can't really boil it down to a single dimension. I mean, you can, but it's like you can, but don't, right? So, anyway, here's something that acts like a 2D list. So for instance, if I say for I in range 5 and I have a list of strings, and then I do something like this, list of strings dot append input. So enter a string. So what this is going to do is it's going to stick 5 strings in here, and then what it's going to do is it's going to say, and then we're going to go through the list of strings, so string in list of strings, and then if length of string is bigger than or equal to 3, we will print out string 3. I guess it has to be bigger than 3. So let's do this and see what happens. So enter a string. Let's enter hello, robots, the game of Go, and I don't know, whatever in the universe. So, oh yeah, and then one more. Let's see, I think I don't, one more string. Don't stop yet. Okay, there we go. So you see what it's going to do? It's going to print out the thing that's at the third index of each one of these strings. So for instance, it's going to print out, for the first string, it's going to print out string 3, which is what? It's hello, so it's HE, this is 0, 1, 2, and then of course the problem is, which one is it? It's actually this one, right? It's the second L because that's string 3, and then R is 0, this is 1, 2, 3, so this is 3, and then of course, why did that not print anything? It's because 0, 1, 2, 3, that's a space, and then this should be 0, 1, 2, 3, so this is the T and whatever, and then this is the hyphen. That's why I put the hyphen in here, because I knew it was going to be another blank thing. So for instance, so basically, if you create a list of strings that's 5 long, and then you output the third character, right? That's what this is doing. This creates a list of strings that is 5 long, and then, I don't know, whatever, outputs the third. And of course, I always put this in, the third character. When I say third character, I mean third index from 0, not third index from 1. So I'm going to comment this code out just because I don't want to be typing in 5 strings every time we do this. So anyway, okay. So what else can you do with 2D lists? You can make like a checkers board. And so let's make an empty list, and then for I in range. And so remember, a checkers board is an 8x8 board. So, well, actually, let's pull up like checkers board, right? Let's pull it up. A checkers board is what? So here it is. So it has 1, 2, 3, 4, 5, 6, 7, 8 by 8, right? So it's definitely 8 by 8. And also, what else should we say about 8 by 8? When you play checkers on it, right, you only put it on, I guess, you put them on the dark squares, right? Or I guess the black squares if it's red and black, and you don't put them on the red squares. So, so that's a decent question. So how do we get that pattern, right? So this is generally how this is one, I mean, should I say that this is the best way to do it? No, but this is definitely one way to create a 2D list. This is just creating a 2D list of stars. And so let me show you how it's working. So, okay, well, let's just run it first. So this is what comes out at the end. It's 8 sublists. Each sublist has 8 stars in it. So how did that happen? Right? So how that happened was, what we did was we created a new list every time. So new list is equal to empty. For j in range 8, we appended into the new list. So I guess if we debug this thing, maybe we can see it as it's happening. So let's debug and just watch it as it happens. So let's hope that it okay, so checkers board. Where's checkers board? Checkers board is here. So it's an empty list with nothing in it. And so now once we step through, we'll have a new list. And where's new list? Here's new list. And then we'll watch as new list gets populated. So when j is equal to 0, new list gets a star. New list gets a star, 3, 4, 5, 6, 7, and then finally 8. So here is the 0, 1, 2, 3, 4, 5, 6, 7. So now new list has an entire list of stars. And so now we want to stick that new list into checkers board. So checkersboard.append new list. So once this happens, the new list will get stuck into the checkers board object. So here we go. Checkers board at index 0 is equal to this list here. And now what we're going to do is we're going to reset this new list, right? New list is going to become empty again as soon as this line is finished executing. So there we go. So the new list is now empty. And then we're going to do it again, right? Now, the new list is empty, but the checkers board at 0 still remembers that list. It still has that list of stars. So now we're going to go through again. So really 0, 1, 2, 3, 4, 5, 6, 7, and then that counted up to 8. So now new list is populated again with another 8 stars. And so what we can do here is then we're going to stick it into the list again, right? And now new list has 2 sublists. It has the sublist at 0, it has the sublist at 1, and each one of those is well, what is it? I guess it is what it is. So, and then let's just continue running it. And so now at the end you'll see, whoops, I didn't mean to do that. Let's see. So if we run it a bunch of times, then we see that finally it populates the list with all of the different sublists, and then I think hopefully it will go to the print line right before it terminates. So now you see the complete list here, right? Checkers board has 8 sublists from 0 to 7. They're all filled with stars. So here's a homework problem from prior semesters that we always used to give. I will give you some kind of similar problem to this in the future, i.e. for homework 4 probably. Homework 4, maybe 5. So normally what we wanted you to do is like have a checkerboard pattern. So for instance, we wanted you to print out some kind of checkerboard pattern, and so let's say that instead of stars, it will maybe print out X's or something. So, yeah, X is good. X is good. So the way that we did that was if I plus J mod, well, I shouldn't do it that way because of order of operations, mod 2, we can print out, we append a star, else we can append an X. And so if you print for line in checkers board, and then we print out line, then what's going to end up printing out, so let's do this. So you see here that this is X star, X star, X star, X star, star, X star, X star, X star, X. So the real question is, why did this work like that? What happened here to cause this pattern? So, and let me prettify the output so that it's a little bit nicer for you to see. Now, don't worry about this joining thing. The join will be explained maybe next week. So don't be too worried about the join. I just wanted to do this so that you would see. Let's space it out. There we go. That doesn't that look like a little bit better? I think that looks a little bit better. So now the question is, how did we make this pattern, right? And so we have to think about, for instance, what's going on with this I plus j mod 2, okay? So remember that this is row 0, and so this is like position 0, 0 in the matrix, right, in the 2D list. So here, 0 plus 0 mod 2 is 0. So remember that if I plus j, right, mod 2 is true, then remember that I plus j mod 2 is equal to 1, right? So basically, if I plus j mod 2 is 1, then it's true. So here, so I plus j mod 2 in the case of 0 plus 0 is 0 plus 0 mod 2 is 0. So this is in the case where it's even, false, whatever, right? So you see that it'll put in an X first. But then we move on to row 0, column 1, right? So row 0, column 1 is going to be In fact, you know what we can do? Let's see. Well, let's just print. Error. Crap. Yeah. There we go. Let's do this, and then we can print out index, and then, like, I don't even know what this line does. It doesn't exist. So, cool. And then let's just do checkers board at index. So keep in mind that this is two different ways to access the checkers board, because this is accessing checkers board at the index. Anyway. Okay, so actually we needed... Now we need unfortunately, now we need a space there. Because... Ugh, terrible, terrible. So, there we go. I think this... there we go. Perfect, that's what I wanted. Okay, so now I can show you different things. So for instance here, at like row, say 4, right, column, say 5, right, 4 plus 5 is 9, and so since 4 plus 5 is 9, right, 4 plus 5 is 9, so 9 mod 2 is 1, and so that's why we append this star. And then, for instance, if we do a different example, so 7 and maybe 3, for instance, so 7 plus 3 is 10, right? 10 mod 2 is 0, so that's false. And so since 10 mod 2 is false, so index here is just the rows, okay? If you actually wanted to do this right, based on like how we should do this in this class, what you would do is you would print out the index with end equals space, and then you would say for, let's say index 2 in range len checkers board 1, checkers board index, and then you would print out checkers board index 2 with end equals 2 space. So I think that should produce the same result. Nope. I think that should produce the same result. Yep. So let's go through how I did this, since this is now completely... So this is now completely legal for the course. So what did I do here? Basically, I went through each index, right? So this is for the rows, right? We went through each row from 0 to 7. And then what we printed out here is we printed out the row number, right? So this prints out the row number here. The column numbers are printed out up here, so don't worry about that. But like, first I print out the row number, and then what I do is I go into checkers board at index. Remember what that's doing. So checkers board at index is the sublist at row index, right? So that is so for instance, the sublist at row 0 is this sublist, the sublist at row 1 is this sublist, the sublist at row 2 is this one, etc. And so, so what this does is it says, for index 2 in range len checkers board index. And so this is giving us a sublist, and it's giving us the range of the length of that sublist, and then going through that, it's giving us the second index, and then this allows us to access the thing at row index, column index 2. So really we could call this call instead of index 2. Maybe index 2 is stupid. And maybe we should call index equal to row, because index is stupid. I think did that fix it? It almost fixed it. There we go. I think that should work. So this is how to generally scan through a two-dimensional list if you need to do that. Basically what you need to do is you need to go through each row, and then you go through each column. And so here's, I know that the length of the checkers board is the same as the length of each sublist, but that's not always true. So for instance, let me make a 2D list here that's an example. So let's see, 2D list is equal to, let's say that it's equal to 1, 2, 3, comma, 2, 3, 4, comma, 4, 5, 6, comma, 6, 5, 4, comma, 7, 8, 9, etc. So here is another two-dimensional list. But here, let me try to cycle through it. So for instance, if I go for row in range len 2D list, that's fine. So this is fine. And then what I do is I say for call in range len 2D list. So this is a problem now. I'm going to print out 2D list row call with end equals space, and then I'll print out an end line here. So this is actually going to result in an error, and I'll show you how that results in an error in just a second. Well, right now. So you see that it printed out 1, 2, 3, and then it didn't print out anything more, right? And you might have seen the red flash by really fast. Remember that standard error is always a little bit faster. So is I columns or rows? Well, I don't have an I here, right? So row is rows and call is calls. Let's find the error. So this is a pretty common error that you can get if you're dealing with lists, and the reason why it's a common error is because what's happening here? Right? So what's happening here is that the total length of the list, so if I print out the len of 2D list here, and then I print out, for instance, print the length of 2D list at row, they're going to be different, right? So for instance, here, the length of the 2D list is 5, right, because it has 5 rows, but each column only has 3 elements in it. So that's a problem, right? And so this is a pretty easy error to run into. And the error that you kind of run into here, right, is that you didn't access the row. And so it might seem a little bit confusing at first, but you'll have to kind of figure out why you're doing that, right? Because here, when you're going through the columns, you have to go through the columns at each row. And so that's why you need to do that. So this should theoretically fix it. Let's see if it does. There we go. So here we have 1, 2, 3. The length is 3, 2, 3, 4. Remember, this is printing out the length each time as well. So 1, 2, 3, then it's length 3, 2, 3, 4, length 3, 4, 5, 6, length 3, 6, 5, 4, length 3, 7, 8, 9. So generally, you might just want to comment that print statement out and just get your list back. So that leads to another question. Do 2D lists have to have the same length for each of each row? So well, actually no. I think in other languages it's not really restricted either. So let's do a wonky list. and then here we'll have that, and then here we'll have that, and then here we'll have an empty list, and here we'll have 789. So is this a legal thing in Python, right? You know, will Python explode? And the answer is actually no, it won't. It's fine. And so let's just copy paste this display function. And instead of using 2D list, we're just going to use wonky list. And then I'll show you that it actually does still work. Here we go. Why did it have a space between... I'm dumb. Okay, so why does it have a space between 4561111 and 789, right? So here it is printing out this list. Let's actually put another print statement in here so it prints out another end line. Cool. So why is there this empty line here? I'll have a drink of water. Yep. It's because so the wonky list at element 3 is just empty. At first I was confused by that because I'm dumb and didn't remember like 3 seconds before that I'd made this an empty list. But as it turns out, I made this an empty list. So yeah, it's going to just print out nothing. You know, and that's what it's going to do. So here is a danger that some people run into. So here's a little bit of a warning. So sometimes people get lazy and you'll just be like, oh, I'll just stick in 0 in here. Right? I'll stick in the length of the wonky list at 0 and then see what happens, right? And now here's the problem. Because each one of these lists has a different length, it's actually going to give you an index error. So it prints out the first list fine, and then it tries to print out the second list, but it realizes that the second list is much shorter than the first list, and then pops out an index error. The index error pops out here. So the index error pops out, and what happened, the reason why that happened was because we used index 0. So there's another case that this could happen. Let's make it work. And then let's do 1, 2, 3. Let's just do 1, 2. So here's an example where it's actually going to run. And so the reason why it's going to run is because the length of the first list is 2 elements. So it's going to run, but actually it's going to chop off everything after the first 2 elements in any list. So watch what happens when I run this code. So if I run this code here with a wonky list of 0, you see what's happening here is it's chopped off everything except for the first 2 elements of every list, because it's not using the length of each sublist, it's using the length of the 0 sublist, right? So if it's using this one, there's really like 2 possibilities that can happen. The first possibility is that it's too short, and if it's too short, then it's going to truncate all the lists when it's like printing or accessing. If it's too long, right? So if it's too short, it's going to chop it, right? It's going to chop something off. If it's too long, then it's going to have an index error or something like that. And if it's equal, right? If you have like an exact board, right? An exact square board 2D list, then it's okay. But only in that condition, right? Only ever in that scenario. So basically, you're going to have to use 2D lists for your second project, which is going to be kind of our take on. Oh wow, I didn't see that on Wikipedia. That's funny. So actually, if the people had searched for that on the yeah, so everything. So that's why you don't do this, right? So that's why you put in row. So let me just do it right now. So here, it's very subtle, right? You only change this from 0 to row. If you put row in here, on the other hand, then it's going to take the length of the wonky list at that row and print out that whole list. So here, you see, here it's working, right? Because we took the length of each list independently. So well, the good news is that you'll have the code up on the GitHub, so you can always play with it yourself, right? So I'll commit it and send it up as soon as I'm done with this lecture. So we'll talk more about 2D lists. What else do I want to talk about? Oh, so let's say we're done with this for now. We're not done with 2D lists. I promise. But I do want to talk about strings, strip and split, and then next week we'll talk about while loops. So, okay. So yeah, let's talk about strip and split. So let's say you have a string. So first let's talk about strip. So let me just show you what this does. So strip is going to strip out all the white space characters from both sides of the string. So for instance, if I do like space, 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 hello, space, 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 right? Then it's just going to give me hello, and you notice that here is the new line, right? There's no additional spaces after this hello. There's no white space before it. On the other hand, so strip will strip out white space before and after. Yeah, you can use split on homework 3. So here's another example. So you see here that strip only strips off, it only goes until the first and last non-white space character. So let's also print out, for instance, or actually let's debug. So let's say t is equal to tab, 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 new line, hello, tab, space, tab, new line, right? So here's a bunch of white space. And now I'm going to print out t.strip. Actually, let's make t prime equal to t.strip. And then we will output t prime. What's wrong with t prime? Nothing is wrong with t prime. Sometimes PyCharm takes just a few seconds to resolve itself. So it'll say that there's an error. Just wait a few seconds if it's doing that, if you're pretty sure that you're right, and it'll disappear. So let's actually debug this. ASDF, don't care. Okay, did that... Oh wait, we didn't debug it, we just ran it. Okay, let's debug. ASDF again, cool. So, where is t prime? Wait, t prime doesn't exist yet. Now let's step one more line. So you see that t is equal to all this junk here. So now let's see what t prime gets assigned to, right? T prime gets assigned to all of the white space is removed. So it doesn't just, so when I say white space, I mean tabs, new lines, carriage, returns, and of course, spaces. Okay. Cool. So that's really all I want to say about strip, is that strip removes white space. You can use strip as much as you want as of now in this class. The last thing I want to talk about is split. So let's input something, a string, tell me a story, and then we're going to print out a string dot split and see what happens. You see, if for some reason it's I think it's all these tabs and new lines. It's having a hard time. It thinks that there's some kind of error. So tell me a story. Once upon a time, there was a pupper who did bad things and stole a plate of cake. Okay. So what's about to happen here, right? What's about to happen? Of course, I think there's some typos in there, but who cares? I'm going to hit enter, and we're going to watch what happens. So, interesting. So split is going to split on white space. So without any parameters in here, with nothing in here, with nothing inside the string.split function, it splits on arbitrary white space. So, so here's another fact about split. So ASDF, because let's tell the next line of the story. Yes, it did. It does put it into a list. So that's what's really nice about it, is that it splits up the words and it puts them into a list. And when I say words, I mean it splits up anything that's split by white space. So pupper, and then I'm going to put a bunch of spaces here, right? Broke the plate because she pulled it onto the floor. So you see, here I have a ton of spaces, right? Now there's two options with what split can do here. Either split can make each space into its own little string and have a bunch of stuff. Not required, but allowed in homework 3, part 3. I guess recommended. But the good news is that split doesn't actually do that. What split does is it just takes this word and then it scans for the next non-white space, and then it finds broke, scans for the next non-white space, finds the, scans for the next non-white space, finds plate. So watch this. Watch this, watch this. Enter. So this is pretty cool, right? It just splits it into the words. It gets rid of all the random white space, all the random spaces that I put in. So you see that actually split is a really great function, because what it does is it kind of, yes. So, and really, this is all you really need, okay? This is all you really need for homework 3, part 3. So for instance, like if you have to add Roberto, then there you go. Huh. Doesn't that seem very nice? Yes, a string, oh, I'm sorry, a string isn't a list, but a string.split is a list. So generally what happens, if you can call something like split list is equal to a string.split, and then you can print like the split list type, split list. So How'd I do the numbers? I don't know. I probably just did like print index. I don't know. I probably did something. Can I go over strip one more time? Sure. So strip, what it does, so strip takes a string, right? Takes a string and gives us back a string without any white space on the front or back. So, how do I misspell? Space. So split, on the other hand, takes a string and gives us a list. I haven't taught slices yet, so don't use slices. Just basically be like if split list 0 is equal to add, right? Print I shall add, right? So you can do something like that. Tell me a story, add Vernon. Do you need to do a numbered output? You don't need to. If you want to, and you can either do like for I in range, like list of things, right? So if the list of things to do is, feed pupper, walk pupper, I don't know, yell at pupper for breaking plate. What you can do is you can always, this is not really the main point of the assignment, but you can always print out, like, for instance, you can print out I plus 1, that'll give us the nice, and then maybe a colon, and then, I don't know, maybe list of things at I. Oops, this needs a let. PyCharm is yelling at me. So let's enter a string, ASDF, remove, whatever. So this kind of does it, right? You can probably do it a little bit prettier if you do this.format with I plus 1. Then ASDF, tell me a story, ASDF. So this is fine, right? When can split? Split is just useful almost all the time. So split is probably the most useful string function there is. And the reason why is because if a user enters a bunch of words, let's say they're entering a bunch of commands. So if you're making some kind of command line interface and I have something where it's like, submit CMSC 201, homework 3, part 1.py, if I make this like s equals this, right? You see here, this splits it nicely for us into, and look how it splits it. It splits it into submit, the command, the class, the assignment, and the file. Isn't that beautiful, right? Like, this is just so useful because obviously you're thinking to yourself like, oh, I mean, so actually the submit script is not written in Python. It's Perl. But who cares, right? So, in Python, splitting this is just like one line. You split this thing, you can, and then you can kind of ask, like, is, if s.split1 is in, say, CMSC 201, CMSC 202, say CMSC 341, we print this is a class, else print no class. What's Perl? Good question. I don't know what Perl is either. I don't know Perl. I think I've written 2 lines of Perl in my life. Perl is just another programming language. But yeah, so here is the here's the submit script, and it's in Perl. It's horrible. It's a god awful language. There's some really awful features about it. There's some nice features about it, but there's some really bad features about it. And so yeah, here's Perl. And so yeah, that's really all I have to say about that. The good news is I am not teaching Perl. It's not a very popular language anymore, so I wouldn't worry about it. Okay. So, yep. For every programming language that you've heard of, there's at least 3 programming languages that you haven't heard of, and that's true for me too. I mean, there's all kinds of wonky programming languages that I've never touched. Is there a simple answer? Yeah, so there's a lot of okay. So, is there a reason for there being so many programming languages? Yeah, I mean, like, basically, in the very early days, everybody was writing in, people wrote code in assembly, right? And people were like, wow, this is really confusing and very difficult to do. So what they did was they're like, let's make programming languages so that we don't have to do this anymore. And so then, the thing is that there's programming languages that work in 2 different ways. So the kind of programming language that we have here, like Python, Java, C++, C#, JavaScript, Perl, basically whatever, they are all called imperative languages. And by imperative languages, that means that they are languages where there's a single line of code it runs, then the next line of code runs, then the next line of code runs, then the next line of code runs. Then there's other kinds of languages called functional languages, which instead of really specifying so much of an order, they specify kind of relations between objects. So they do also run in order, so they're a little bit imperative, but functional languages work kind of differently. That's like ML, Lisp, Clojure, etc. And so basically the idea here is that there's 2 different families of languages, and then within the imperative family, people were like, well, C++ is kind of the low-level language. That's if you need access to pointers, hardware. Java was built to be platform independent, and it's an interpreted language. Python was basically built to be like a scientific computing, fast programming language. Well, fast to program. But the trade-off is speed, right? Because, for instance, C++ will run at, let's say C++ runs at speed 1. Java runs at speed 1/3, and Python runs at speed 1 about 1/10. So if you are able to port code from Python into C++, then you can get a huge performance, like a 10 times performance boost. But the thing is that Python is usually a much easier programming language to use than C++. It's better. I think Python is better for web development. It's just a friendlier intro language sometimes. C++ is kind of angry with pointers. Java protects you from pointers as much as possible. In Java, they're all called references, and you don't actually have access to the pointer value itself. So, Well, so the reason why there's a decrease in speed is that C++ is actually a compiled language. And so what I mean by a compiled language is that a compiled language is something that goes directly from, let's see, where did I put my tablet? Here it is. So a compiled language is something, so here is code. Here is the compiler. And then here is machine language. Right, so you think of this as, right, this is the actual binary that the machine is running. And so this goes into the machine. And so this is the C++ model. There's also C. The Java model is that you have code. It's converted into what's called Java bytecode, which is then run on a program. So this is another program called the Java interpreter, which then converts in kind of half real time, half not real time. It converts it into machine code. And here's your machine. Well, an interpreted language runs on some kind of interpreter. So basically this is an interpreted language. But most of it's compiled into a kind of, so there's a compilation step, which is what gives Java a little bit of a speed boost. Python, yeah, class is over. On the other hand, starts as code. And so it kind of skips this step here, and it goes straight to the Python 3 interpreter, right? So basically, whenever you're running Python 3 myfile.py, that is what that is doing. So you're not actually running, in a sense, you're not actually running your code. You're actually running the interpreter and telling the interpreter to eat your code, right? So that's what you're doing. And so basically, this is why Java is a little bit faster, because it's able to pre-compile a lot of what it's doing into Java bytecode. Python 3 has the slowdown because it compiles and interprets at the exact same time. And so interpretation is basically, it converts it into machine code in real time, right? And this is real time. And so basically all the work is done here in real time, and that's why Python is slower. You see here, some of the work, this is done at compile time, and this is compile time. So some of the work is done here, which speeds you up a little bit. And so, but anything done at real time, when you're actually reading code and compiling it in real time, that's going to slow you down, right? On the other hand, Python is extremely versatile. There's a lot of good reasons to use Python, and for like a vast majority of internet applications, so you're not really worried about this slowdown. So the kind of speed up that you get here is not vital, right? The speed is not vital on the internet, because like if you even ping Google or whatever, it takes like 23 milliseconds to ping Google about, at least from my house, which and the amount of time it usually takes to run a query on a server is like 2 milliseconds or less. So the thing is that the speed of Python code is fine. Like you don't need to go from like 2 milliseconds to like 0.2 milliseconds, because you see that the speed that it takes to go from your computer to Google or to a server and then back to you, right? That's the 23 milliseconds. Their server only takes 2 milliseconds to run, so they don't care that it takes 2 milliseconds rather than 0.2 milliseconds, because you'll never notice that speed difference, right? That's within like the standard deviation of your communication time with the server. So anyway, yeah, so basically that's the explanation of why Python takes a little bit longer to run, because Python is actually doing all of its work in real time. That's why when you get these like out of bounds errors, when you get all these errors in Python, unless it's a syntax error, most of the errors occur while your program is running. Whereas in Java and C++, you're going to have to get used to compiling your code. You'll get errors before your code runs, right? Errors that prevent your code from even compiling and running. And in a way that's bad, because you're like, well, you know, sometimes you just want code to run and it'll fail when it fails. But sometimes you actually want to know what's going wrong before you even run your code, because it could cause problems. So for C++, your code has to basically be 100% perfect in order to even compile, right? And it compiles into machine code and then it runs. And this is real time here. And so generally, nothing is done here except for just running your machine code. So that's why it's fast. This is like middle. And this is, I would call this slow. But anyway, okay. So I think that's basically all I have for today. I guess I've talked about all of this stuff. Anyway, okay. Cool. And we'll talk more about this kind of stuff later. This is just like a quick little diagram of what's happening with programming languages. Okay. That is all for today. I guess I need to find my outro. There we go.